Excellent. So as a reminder, I'm going to be calling on you and practicing with your names. So if I make a mistake with your name or pronouncing it incorrectly, please just correct me because I care that I learn your names and that I pronounce them correctly. Okay? So let's go ahead and take a look. Some of these are expressions, some of these are equations, some of these are formulas, some of these are more than one. So what I want you to do is go ahead and look at your partner's bell or letter A and raise your hand if you have the exact same response. So take a look at bell or letter A with your bell or of your partner and see if you have the same thing. Great, thanks hands down. So it looks like you were in agreement with your partner. Adam, what did you guys say? Expression. Raise your hand if you also had expressions. If you also had expression in the room, that's great. An expression, right, is a combination of variables, numbers, operations, but there's no equal sign. So A is an expression. Letter B, go ahead and check your partner. Raise your hand if you have the same response. Same response. Good, thanks, hands down. Margot, what did you ladies have? Formula and equation? And why did you have formula and equation? It's an equal sign and it's more than. Absolutely. So when we have an equation, right, that relates two expressions together, and it's one variable written in terms of one or more other variables, then we know we're dealing with a formula as well. That was part of your vocabulary that you're reading in your reading questions. So once again, an equation, right, relates two expressions. So it's one expression set equal to another expression. The formula has the addition that it's one variable solved for in terms of other variables, one or more other variables. So E is both a formula and an equation. Thank you, and thank you for your explanation. So then letter C is going to, yes, be an equation, but we see it's got the equal sign. Is this a formula or not? That's the only thing remaining. So what I want you to do is we're going to do one finger and a two fingers. So one finger is yes, it's a formula, don't do it yet, and a two fingers is no, it's not a formula. Everybody think, and then you're going to show me. So yes, this is the formula. One finger, two fingers, it's not a formula, go ahead and show me. Everybody, give me fingers. Not one finger, oh my gosh. So, yeah, no, it's not, yes. So peace out. This is not a formula. It would be a formula if x equals 15 plus a, right? If that one variable is equal to one or more other variables in the expression. So this is not a formula because this other side is just not other variables. Great, thank you. So let's go ahead and take a look then at D. Now that we've had some practice, let's go ahead and share. What are those, Taylor? Beautiful. Equation and formula. Raise your hand if you have the same as Taylor. Equation and formula. Rock solid. A plus B equals B plus A. Oh, gosh. That's true. Yeah, that's true. What do you think about that? Okay. Equation, I would agree. Why did you say formula for that? Absolutely. This left-hand side or this right-hand side, it could be either side, isn't solved for one variable alone by itself, instead equal to one or more other variables. So this is not a formula just because it's not A equals blah, blah, blah with B. Or it's not something, right, with multiple variables equals B alone on one side. So this is not a formula because it's not one variable solved and be written in terms of other variables. And lastly, F. What does the letter F then for? The expression only, raise your hand if you have the same as mark for F, expression only, no equal sign, great job. So that's old news. We know our vocabulary now from our reading sections. 1-1, 1-6, and 1-7 last time. So I'm going to be using those as we continue on. First we're going to do is grade our homework assignments. So I've already gone around the room and I've checked those reading questions. Those reading questions you can complete on the reading log, 1-1, 1-6, and 1-7. It'll be much smoother on Tuesday because now you guys know exactly where to look. Your assignment sheet, the purple assignment sheet tells you exactly what to do each day of class. You'll have the reading questions, do those first, complete those on the reading log, and then you'll go ahead and answer those other problems that are detailed. Today you'll have the addition of a worksheet as well, but it's not very long, so we'll go ahead and see if you have a little bit of time at the end. This is how we grade this class. You are going to grade your assignment in two different ways. The first way is based on completion. Did you do the work? Did you put in effort? So you'll get a completion grade, right? And we're going to do that in pencil. So we're going to do our completion grade in pencil. Our completion grade is an indication of your effort. I'm trying to find just a regular wooden pencil for my visual aid. So we're going to do a pencil grade for our completion grade. And then, after we get a completion grade, then we're going to use our grading pens to go ahead and do an accuracy fraction. An accuracy fraction that lets both you and me know how well you're doing in terms of the accuracy of your answers. So once again, every assignment, we're going to grade two different ways. We're going to grade based on completion, which is just effort, and we're going to grade on accuracy, which is how well the answers and you're doing. The one that goes in Infinite Campus is your completion grade. So in this class, if you show your work, box your answer, right, for every single problem and do your best, you can get 100% on your assignments. Okay? You can get 100% of your assignments in Infinite Campus. But that doesn't do any good in terms of how well you're understanding the material. That's why we do our accuracy grade. So each and every day we'll do our accuracy grade as a fraction. We'll end up circling that in pen, your grading pen. And then you can get that instant feedback to see how well you're doing. And me as the teacher, which I collect the assignment every day, can see exactly how you're doing as well, each and every assignment. Right? You shouldn't wait until the quiz to figure out, gosh, I really don't know this stuff. I'm not doing very well. Each and every day, your grading of your homework assignment should act as that immediate feedback to make sure you're understanding the current concept as we go through the course. So once again, we need two things for our grading. We need our completion fraction in pencil and our accuracy fraction circled in pen. First, we'll do the completion. So everybody take your pencil. We'll go ahead and go through it and show us how many problems that you did out of the 16 problems in your work. You'll see, hey, first day I did all 16, so what I'm going to do is I'm going to give myself credit for those that I completed. 16 pencil out of 16. I'll divide, enter, multiply by 4, and those 4 possible points are based on my homework completion. Then, this additional 1 point is if you did your reading questions for that assignment. If you did all 3 reading questions, then you get that additional point of 1 added on to your completion score for your assignment problem. So, you've got up to a possible 4 plus 1 gives you a possible 5 for this first assignment if you did all 3 reading questions and you did all 16 questions. Maybe you fell asleep, right? Halfway through watching your Pretty Little Liars reruns, you fell asleep. You only got 8, right? 8 homework questions done. But you did your reading questions, so you get 8 out of 16. Enter. Times 4 is 2, plus the reading question point is 3. You get a 3 for this assignment. So once again, everybody, you get up to 4 points for completion, and then an additional 1 point possible for reading questions for that day. Sometimes there's 3 reading questions, sometimes there's only 1 reading question. In either case, it's just worth an additional 1 bonus point on your assignment. There are several assignments that don't have reading questions. Those will just go into the campus out of for completion of the problem. Okay, now, you're going to, from time to time, right, get a decimal when you do this division. That's fine. At the end, when you added your reading question, right, point, you're going to round to the nearest half point. So nobody's going to turn in a page that says 4.3333. We're going to round to the nearest half point. The only possible homework scores are 0.5s or whole numbers. So you can get a 4, you can get a 4.5, you can get a 5. You won't get a 4.33. You won't get a 4.3. You're going to round to the nearest half point. So if I did my calculations and I added on my reading question point and I got 4.333, what am I going to round to for my completion score? 4.5, right? 4.5. You're going to put your completion score in pencil, and you're going to do that nice and big, and you're going to box it. This is an easy way for me to find your completion score and get you credit in Infinite Campus on my grade sheet and the computer, so you're getting credit for the hard work you're doing as I find. This is in pencil, it's boxed, this is the nearest half point, and it's based on effort. The next, I know, because now we're going to circle one. Ready? Now we're going to put our pencils down. We've already got your completion score. We're pencils down, and now we're with our grading pen. It doesn't have to be the classic graduating teacher pen, but it could be, because it's pretty sweet. Or it could be a purple gel pen, or a pink highlighter, or electric blue. So let's talk about the one you use electric blue. Okay, great. Use electric blue. It just has to be different from your pencil. Ready? Now we're going to go through and we're going to use our grading pen, and we're going to check for accuracy. If we get a question wrong, no problem. You can just put a little line through the problem number and then put the right answer there next to it. That's totally fine. This is not going to affect your grade in Infinite Campus. It's just a way to give you immediate feedback, and me, as the teacher, I need to know, right, not only if you're doing the assignment based on your completion grade, but how well you're doing on the assignment in terms of accuracy based on your accuracy fraction circle. So here we go. So these first ones, they're varied answers, and so You could have lots of different things. Equations and formulas are both algebraic sentences with equal signs. The formula has a single variable on one side set equal to one or more other variables. The equation has to have an equal sign, but an algebraic expression doesn't have an equal sign. For A, it's D decimal. B was just an expression. 5, you can make up your own expression. 6, you need to have an equal sign and a variable alone on one side, set equal to one or more other variables. 7, yeah, in algebraic sense, it includes an equal sign. B, yeah, it can be considered a formula solved for C squared. Kind of. One variable is alone on one side. It's just C squared, not C equals, so you could consider it solved. An equation. 8, there was a mistake in the teacher solution, but I think this does accurately reflect the book now with change, so this is -5. I think that's right. Nine 306 minus 60n could be an expression for that. A, so 176 at the end of the day. B, you did subtraction inside the parentheses, then raise to the exponent, then you divide, then you multiply, and then add. We're going to need that later for our activity. 12, there was a mistake here. The way to make that happen, there has to be a little square there down at the bottom. Squared in order to get to 25. And so some textbooks had this and some textbooks didn't. So we put a big asterisk because your textbook might not have had that. And that was an issue with the publisher. The other way to make that happen then would be those parentheses around the 5 times 5. Ben? Yes. 176. Subtraction first, then exponent, then division, then multiply, then add. You don't have to do as much, but you have to put them so I can see your thought process. 14, it's a great problem, right? That had the fencing, the 1,040 feet of fencing, and the river that was acting as one of the sides of the 10. So 1,040 minus 2x would give the length L, right? On the fence. Area would be x times L. Substituting your expression for L would give you x times quantity. 1,040 minus 2x, that's pretty sweet. It's saying that's at least 60,000 square feet. At least translates into greater than or equal to. 1572/17 to be exact, that's about 4.2 on your calculator. Almost there, guys. Almost there. 18A is 122.5 meters. 18B is 20 meters. C, we can see Mars G value, acceleration due to gravity, smaller than Earth. 25 is C calculator. 26 is an octagon. 27, A, X is -9. B, yes, it checks out. I think that does it. Yes. I'll let you finish up there. Those last ones. What you want to do when you're done correcting with your grading grid, you're going to go ahead and total up then your number correct out of those that you did. So if you did all 16 and you got 11 that was correct, you put 11 out of 16 next to your box, completion square pencil, and pen. So at the front of your page, you now go the number that you got correct out of the number that you did. And then circle it nice and big. So I've got box score completion and pencil, circled accuracy, fraction, and pen. This way I can see two things. Are you doing your homework? Are you doing it correctly? Right? Are you doing your homework? Are you doing it correctly? Caitlin?
What if there like a problem with like A's and B's and only got one goes wrong?
You could take out 0.25. You can take out 0.25. Adam? Yeah. Don't count it against you as a publisher. And again, this is feedback for you, but for me, it doesn't affect the grade. So if you had the 12 here versus 11 here, it's not going to make a difference. The other thing is, if you fell asleep, right, because you're watching Pretty Little Liars reruns, you only did 8, right? You would put your number out of 8 for your accuracy fraction. You've already done your completion, so about a 16. So, like, if you fell asleep, but you got all 8 right, it means you're doing well. You just didn't do all your homework. So you put 8 out of 8, right? This is always out of how much you did for your accuracy fraction. As opposed to completion, is always how many there are. Better? They'll go quickly. All right, so now we got to make sure we've got our name on the top right. So we've got our name. Right. We've got our assignment number. This is assignment number 1, and we've got our section. Our section is 1A. 1A in the alphabet. So we're going to go ahead and put something on the top right of our paper. So we've got our name. We've got assignment number 1, and we've got 1A. Right, make sure you have this on the top right of your assignment. Your infinite Canvas score for completion is box with pencil. Counted there is half point. Your accuracy fraction is circled in pen. And now we're going to go ahead and pass directly forward from back to front. Please wait till the people behind you pass yours forward before adding yours to the pile and continuing on passing. Don't do left-right passes. Just keep them all in a row because they'll make it so much easier to return to next class. So straight from back to front, please. Straight from back to front. I appreciate your help. Front rowers, if you make sure they're facing the same direction, they'll make it way easier to record. So thank you for your help with that. I appreciate it. And as we do this more, the procedure will become second nature. Thank you, ladies. It'll go a lot quicker on Tuesday, Thursday. Okay. Today is reporting day, and I'm super excited. There's some things that we need to take care of. So we've already done our reading question check. We've done our homework check. We want to get your signatures from the course policies and welcome letters. Many of you already have your signatures out when I was going around for Bell. Some of you didn't get your signatures. You'll have to do that. Show it to me on your own. At this time, I ask that you take out your signatures if you had your parents sign it. Take out your signatures if your parents signed it. You're going to go ahead and clear off that last thing. Make sure that your name is printed legibly so that I know what you give credit for and the Canvas for printing signatures. Once again, make sure that your name is printed legibly so that I can record properly on my grade sheet and an Infinite Canvas. After taking out your signatures then, again, same thing, directly forward. Directly forward, wait till you receive the people behind you before adding yours to the pile and continuing the pass, okay? Thank you. If you don't have your signatures, make sure you get them to me tomorrow at the P-Day, but you can still bring them by. Give you credit, make sure that you bring your signatures by, but you have to do that on your own. I'll just do that on your own, so make sure you bring me those signatures, okay? While we're waiting, when are we checking for your binder and divider? When are we checking for your binder and your dividers? Wait a minute. Yeah, we're going to be checking on the 8th, Tuesday, first day after beginning. Thank you guys. Thank you. Okay. So in our agenda, we see that we've taken care of all this stuff. Now we get to our objective. So each day on our agenda, you'll see our objective for the day. Our learning objective today is to be able to solve equations and rewrite formulas. Some of the equations we're dealing with today are going to seem easy to you. It's going to seem like review, and that's great. However, I want you to follow the suggestions to you in the guidelines to solve the equations activity, because it's going to make your life so much easier when we get to the rewriting formulas part, which is going to be quite tricky. In fact, there's a couple of tricky ones, not only on your assignment today, but also coming up on your first quiz. If you look at your purple sheet, you'll see that you have a quiz coming up mid-unit, right, that has some tricky equations on it. You want to make sure that you're comfortable solving equations and rewriting formulas. So today we're going to model solving equations as a logical process of reasoning that undoes our forward evaluation steps, our PEMDAS that we know from middle school. We're going to reverse and undo those forward steps in order to get our solving steps. In this manner, we'll be able to create a recipe that will be used to solve any equation, right, using this process of reasoning and logic. So that's why I'm going to ask that you go ahead and follow along, even though some of these are easy, right? And you can do it without having to write down this recipe, right? Because they seem super easy in review. from middle school, and that's great, but they're going to get trickier. So thank you for following along, for playing along, for buying in, and for humoring me, because it's going to make your life a lot easier. So that's where we're headed. We're going to solve and check equations, evaluate expressions and formulas. We're going to rewrite formulas for the indicated variable, and then you guys already did a great job with equation versus expression versus formula. What allows us to solve equations are our old school properties. From middle school, we know that the distributive property results when we have some outside factor, and we multiply that outside factor through a sum or difference term by term. There could be 20 terms here connected by addition or subtraction. That outside factor will multiply each of them in turn to create my new expression. The addition property of equality simply says that if I add something to one side of the equation, to keep that an equation, I need to add the same thing to the other side, the same thing to the multiplication. And then this is one where sometimes students do some. The opposite of a sum theorem is really just distributive property in disguise. It's like a -1 hiding outside the parentheses. I multiply that -1 term by term through the parentheses, so I'd be taking the opposite of A and the opposite of B, so I get -A minus B right here. Where several people made mistakes on the pretest just yesterday, right? When they didn't distribute that negative all the way through the parentheses, they only did it to the first thing. So you want to make sure on the lookout for that. We'll see that in our example later. Okay. For our set today, dear algebra, please stop asking us to find your x. Never coming back and don't ask why. Why? Thanks again for playing along with our process today. Some of the equations might seem juvenile and like review, right, to you, and that's okay. It's going to make it a lot easier when we get to our rewriting formulas to close out today's note. So thanks in advance for trying to buy into this process, because it's going to set you up for success in the rest of the year. What we're going to do right now is stay in our partner pairings. We're not going to move the desks at all. What we're going to do right now is you're going to read the first 2 pages of the handout on solving equations. You're going to get 4 minutes to do this, and when you get to the end, I want you to go ahead and stop, because then we're going to talk about the arrows together. So once again, you're going to go ahead and take 4 minutes, read the first 2 pages, that's front to back, then stop at the end, and we'll come together with a time repeat. Some of you may still be reading, and that's okay. Some of you will have finished already. Go over to 4 minutes, and I'm going to keep us on track. Okay? Thank you. fine. So what we're going to do in the interest of time is to come together right now, and we're going to take a look at this notion of listing my forward steps, order of operations, back from evaluating expression principle, and then reversing and undoing those forward steps in order to get our solving steps, our recipe for success to solve any equation. The first ones are easy. It might seem like this takes longer than if I just solved it the old middle school way by my line in the middle of an equal sign, right? And that's true for these first easy ones. But what we're doing is we're setting up a foundation to build on more and more complicated ones. So once again, thanks for playing along with me. Reminding me that this process of reasoning is going to make your life easier when we go beyond into FST and 3. So let's go ahead and take a look at 1A. So this is the next page, page 3 top. We're going to look at if you were to pretend this were an expression, cover up that equal sign. Cover up that equal sign. If you were to plug in a variable value for x to evaluate, back in middle school, what would you do first? You would times it by 6. So multiply by 6 with the first forward step, my right arrow. Then I would do what? I take that number and I would subtract 7 from it. So I'm going to subtract 7 from it, and that's how I would get the 6x minus 7. If I had set that now equal to 38, and reverse and undo those forward steps to solve, the first thing I would do is undo that last step. Well, my last step was subtract 7. So we know we undo that by doing the inverse operation. We add 7 to 38. When we did that, we did 38. Adding 7 out, moving all the way up, carry the 9, screw the inverse. I'm getting 45, is that right? 45? Good. And then I would undo that first step. The first step, forward step, was multiply by 6. I'm going to undo that. The inverse operation will be divide by 6. So I get 45 divided by 6. And I may or may not be able to reduce that on your quiz. You could have done it like this before. Yesterday, that's fine. Today, we'll still leave it as an improper fraction for reduce. It's just that 6 goes into 45 7 times 42 with 3 left over, so I'm getting 7.5 or 7.5. Okay, so we went ahead and listed our forward steps, and then we reversed and undid in order to get our solving steps. So what I want you to do right now is go to B, and you're going to, with your partner, complete the remainder of my forward arrows, for an evaluation. By plugging in something for x, if I were to plug in something for x, the first thing I would do is multiply by 5. Then I would subtract 7 to get 5x minus 7. Then I would, don't say it out loud, go ahead with your partner, complete these forward step arrows. Then set it equal to the number, set it equal to 12, and reverse and undo those forward steps. Nope. Stop at B. Stop at B, pencils down, and we'll come back together. So stop at B, pencils down, we'll make sure we're good. Okay, some of you might still be doing the solving steps, and that's fine. I just want to get the forward steps. So we subtracted 7 where we left off to get 5x minus 7. Next up, how would we get to this? How would we get to the square root of 5x minus 7? What would we do, Jackson? Yeah, we would have taken the square root. So we would have taken the square root. And here, my final step, Olivia. Okay, we would have divided by 2 to get my final expression. Now we set that equal to 12 in the equation and reverse and undo those. So what undoes division by 2? Multiply by 2 was already there. So we'll take 12, multiply by 2. Write it down. Let me get 24. Raise your hand if you already had 24 with your partners. So already had 24. Good. Next, reverse and undo step. We need to undo taking a square root. Well, what would undo taking a square root? Oops. We can square it. So we undid taking a, sorry, we would square it. So we're going to go ahead and do 24 squared. It would be 24 times 24, and I go to my calculator for that, and I get something bigger than 576. It's 576. 576. Then we undo subtract 7 by add 7. Everybody do it. 583. Awesome. And lastly, we would undo multiply by 5 by dividing by 5. So my last one will be divide by 5. And now we'll just leave it in the process right now. 583 divided by 5. So we've gone ahead and listed my forward steps. To reverse the undo to get my solving steps. Taken my number and applied those solving steps to the recipe for success. And did anybody get the 583 fifths already? So did anybody get the 583 fifths? Whether you change it to a decimal or not, that's the process. Okay? So, right, we could go ahead and write down that x equals 7.5 and x equals 116.6. Okay, awesome. Okay, now what we're going to do is we're going to switch into our probability group. So you've done some work individually, right? Today we've done some work with a partner. Now we're going to go ahead and go into our probability groups. Our probability groups we'll use for activities, right? And our activities we're working with strength of minds, putting our minds together. By talking it out or verbalizing our thought process, you're more likely to understand it and remember it longer. So that's why we're going to do some probability. We won't do this all the time, right? But we will do it from time to time when we're introducing new concepts or when it's a good activity and opportunity to discuss, right, and share and verbalize the mathematical processes behind our approach. So what we're going to do is we're going to, not right now, but just a minute, we're going to switch to our probability groups. It's going to look like this. Row 1 is going to spin around and join row 2 to form a group of 4. So row 1 is going to spin around and form an island of 4, okay? And that's going to hold true in a group of 3 there, and a group of 3 there, a group of 2 there, and 3 and 4, 3 and 4, 3 and 4. Okay, so let's go like this. How about Olivia, if you want to come up and join Caitlin, and Jackson, if you want to go back and join Carson, then we have all groups of 4. You're going to spin around, okay, not yet, but we're going to work together through the rest of this, and you're going to, when you all agree on one of these stamped eligible items, you're going to raise your hand as a group when everybody agrees, and I'm going to come to this group all at one time, and I'll issue stamps all at once. So we're not going to do one person at a time, you're going to all work together. When you guys talk it out and agree on a response, right? You're going to stay together, you're going to raise your hand up, you're going to come and get your stamps all at once. So go ahead and do a quick little circle around your stamped eligible items, guys. Wait. Put a little circle around 1D, 3A, 3D, 3F. These are the ones you're going to get. After you circle those, go ahead and spin around and form your groups and begin. Make sure you all agree before you raise your hand and I'll come over to you and get your stamps. Yeah, you do one. When you get done with 1D and all agree, then you raise your hand and I come and get you. Then you keep going. If I'm busy with a different group, then you can go on, okay? And I'll catch you because it's more to me. Thank you. There's 2 solutions for 1D, 2 solutions, and there's 2 solutions for 3F. Thank you, ladies and gentlemen. I appreciate your help in turning this regular position. Now what we're going to do is we're going to shift gears from our activity back to our day 2 notes. To go ahead and do a couple examples together of some special situations, including those with multiple solutions. And then we're going to go ahead and take care of our closure and maybe have a chance to start assignment. So once again, we're going to find your note sheet. Day 2, everybody go back to your note sheet. Day 2, underneath color. We're going to take a look at a couple of situations. They're a little bit different. Can we find it? Great. So some of these are easy cheesy. In middle school, we saw that our forward steps fell short if we had variables on both sides. So as we look at number 1, we notice for the first time we got variables on both sides. No problem. In this case, we'll simply use our inverse operations, add or subtract, to get our variable alone on one side. So we want all of our a's on one side of the equal sign. To do this, we've got choices. We can move this positive 2a to the right side by subtraction to undo that positive 2a. Or we can move this positive 5a to the left side by subtraction. Subtract the 5a from both sides. Would you rather subtract 2a from both sides or subtract 5a from both sides? Which would you rather do? Raise your hand. Which would you rather do? Logan? 2a, how come? I'm with you. You can certainly do either way, right? Personal preference. But I would do the same as Olivia because then I can keep my variable term positive. So when you have choices, right, there's more than one way to do it. So I would subtract 2a from both sides. We'll go ahead and get rid of the variable on the left. We still bring down the negative 7. We still bring down the equal sign, but we can combine like terms now. 5a minus 2a, 3a, I still have the plus 17 showing. And then we'll continue on with the process. Now that we have our variable our variable expression appearing once on one side of the equal sign, now we can do our 4 steps times 3 plus 17. So to undo those, we would subtract 17 and divide by 3. In the interest of time, we'll go ahead and do that subtraction right now together. Bring down our equal sign. And I'm getting 3a is equal to negative 24. Go ahead and tell the class that you can finish that out to both sides. What would you do? Easy. Then you will divide both sides by 3 to make the variable a alone. So I get a equals, sometimes it's reduced, sometimes it won't. In this case, it's the numerator, so I'm getting a equals negative 8. Quick check before I box, I'll go back to the original. 2 times negative 8 is negative 16 minus 7, that's negative 23. Does negative 23 equal question mark? 5 times negative 8 negative 40 plus 17 is negative 40 plus 17 is also negative 43. By golly, I now feel confident boxing my answer because I have checked. So we can handle variables on both sides, no problem. Number 2. Here, we're ready to rock and roll, except I got variables on both sides and parentheses. So here's our favorite property that starts with a P from middle school. The distributive property, I can simply multiply. I can multiply this outside factor through the parentheses. 4 times 2n is 8n. Plus 4 times 3 is 12 equals. I also have a distributive property on the right-hand side. Look at this negative sign in front of the parentheses. This can be handled like a negative 1, and I will distribute it through the parentheses in turn. The opposite of the sum theorem is just a complicated name for saying distribute that negative through everything in the parentheses. That'll change everybody's sign. So on the right-hand side, I'll get 6 minus a plus 2. What? Where did we get that plus from? Negative 1 times negative 2 is positive 2. So negative times negative is positive. So make sure you got that plus. And now it's just like the first one. We'll simply add or subtract to get the ends on one side, and then use our regular process. So it looks to me like I would rather add one end to both sides, then subtract 8n from both sides. For the same reason that Olivia gave earlier, I'd rather have a positive variable term if I had the choice. You can do whatever you want. Just make sure that you're being systematic about your method and showing it work. 8n plus n is 9n. Plus 12, bring down the equal sign. Still have the 6, still have the plus 2. Combining like terms, same side, same operation. I can combine the 6 plus 2. There's no subtraction here. I'm going to do 6 minus 2. They're the same side of the equal sign, but they're combining like terms, same side, same operation. And so I can do it quickly, right? 9n plus 12 equals 8 if you haven't already. Now we'll go ahead and follow our strategy. Plugging in variable value for n and evaluating forward, so middle school would be times 9 plus 12. So to undo that, we'll subtract 12 and divide by 9. So subtract 12 to the first solving step. Bam! 8 minus 12 is negative 4. Then we'll go ahead and divide. We'll split by 9 to finish it out. Cool, guys, arm. And I'm getting n equals negative 4 19. And I would totally check that if we had more time, just like we checked our negative 8 by 5. And we're good for now. What questions do you have about our first two? Another thing we look at is yourselves in your pretest yesterday, and some people, right, some people weren't sure how to handle the multiple fractions with different denominators. So we're going to share a strategy to clear the fractions. In order to clear the fractions, we can multiply by the least common denominator. So our strategy to get rid of the fractions in one fell swoop, right? Fractions, the F word, fractions. We're going to go ahead and multiply everything, both sides, by the least common denominator. So we're going to multiply by the least common denominator as our strategy to clear the fractions. Then we'll have an equation that doesn't have fractions going on. So one fell swoop, we can do that. Go ahead and take a look at these denominators. One denominator is 3. One denominator is 4. So my least common denominator will be the first number that each of these denominators divides into each. Go ahead and tell your partner probably what that is. So the least common denominator here, you're calling it here. Alright, Carson, what did you guys come up with? 12. Raise your hand if you have the same as Carson. 12. 12 is good. Thank you. So we're going to multiply both sides by 12. So we're going to do 12 times n over 3 plus n over 4 equals 5 times 12. Right? So we're going to multiply both sides by 12. When we do that, watch what happens. 12 over 1 times n over 3 is 12 times n over 1 times 3. You can do this in 2 steps, or you can do this in 1 step. 12 times over 1 times n over 4 is 12 times n is 12, and over 1 times 4 is 4. And on the right hand side, I've got 5 quarters small. 6. Watch what happens with these fractions. 12n divided by 3 is the same as 4n. 12n divided by 4 is 3n. 4 fractions equals 60. And now we've got same side, same operation. I'm getting 7n equals 60. I'm dividing both sides by 7. I'm showing that. And I'm getting n equals 67. So if I have multiple fractions within the same problem, we're going to multiply both sides, every term by the least common denominator. And this way I can clear the fraction from one fell swoop. What do I like about the second blue line as opposed to the first blue line? The fraction. Okay. We can do a similar strategy when we have decimals. We can clear the decimals by multiplying both sides by the power of 10. The power of 10 needed to clear decimals. Just like here, my longest decimal place is 10ths. So if I multiplied everything by 10, I get rid of the decimals in one step. Let's do that with both sides. I'm going to go ahead and multiply both sides by 10. All the way through both sides. So if I multiply 10 times the left-hand side, all it's going to do is change the 0.2 to 2. I still have 2 minus 20. If I multiply 10 through the parentheses, then I would be multiplying by 10 twice. I can multiply by 100. I only do the 10 times the 0.2 is 2. Equals on the right, I only do the 10 times the 0.4 is 4. So once again, that decimal moves over one place for every power of 10 that it multiplies by. And now it's the same as before. I'll distribute, get rid of the parentheses. I get 2 times t is 2t minus 2 times 20 equals 40 equals 14. I'll subtract 2t from both sides. Then I'll get negative 40 equals 2t. Dividing both sides by 2. T equals negative 20. I do that right with the signs negative divided by positive overall negative. Do that right? Very good. Awesome. Okay. So we've got 4 ones that we've already seen most school in our pretest yesterday. We've got something a little bit new for 5 and 6. For 5 and 6, we've got different kinds of equations. In number 5, we've got a squaring equation that we ran into an activity. And then number 6, we've got an absolute value equation that we ran into our pretest yesterday. Today we're going to figure out how to solve these type of equations. Both of these have multiple solutions. So we could have multiple solutions anytime we're solving a squaring equation. We saw that in our activity resulted when we undid a squaring by taking a square root. There's 2 numbers such that when squared equal a given result. If I said what squared equals 36, right? You'd say 6, because 6 times itself equals 36. But what other number squared equals 36? Negative 6, right? Because negative 6 times itself, negative 6 equals positive 36 also. And so there's two possible answers that we can look for whenever solving a square. Same is true for absolute value. Recall in middle school, absolute value refers to, above all, a distance back to 0 on the number line. Well, just like there's two numbers such that when squared equal a given result, there's two numbers that are equidistant from 0 on the number line. One is over here, a positive number, right? And one is over here, a negative number. If I said what numbers are 5 steps away from 0 on the number line, you'd say 5 is 5 steps away from 0 on the number line. But so is negative 5 is 5 steps away from 0 on the number line. So there's two possible solutions whenever we're solving absolute value equation because of the distance and whenever we're doing squaring. It doesn't mean there's always two, right? It just means we have to be on the lookout for two solutions, multiple solutions. Let's do it. Great. If I use my forward steps, I covered up my equal sign, and I said, what would I do if I plugged in a variable value for x, any value in like in middle school? The first thing I would do is square it. So I'll raise to the second power. Then I would subtract 4. So to get my solving steps, I'm going to go ahead and add 4. What we're just going to do would be add 4 under that last thing, and then square root. However, we must take the positive and negative square root, just like your activity. When you're the positive and negative square root of 25, you got 5 and negative 5. Or at the end, so if you got your final state. The positive and negative square root of 7 was positive root 7 and negative root 7. So we have two things here. And now we can do our solving steps. Ready to go. Plus 4 plus 4. X squared equals 16. Positive and negative square root. So if x squared equals 16, then x is given by the positive and negative square root of 16. And sometimes I'll be able to reduce that, sometimes I won't. But either way, I get the two different paths. One set equal to the positive square root of 16. One set equal to the negative square root of 16. Sometimes I'll have stuff after the fact. Sometimes I'll stop right here. It looks like that's my final answer for x alone. So positive square root of 16 is 4. Negative square root of 16 is negative 4. So I get two different answers. Multiple solutions, you guys. Multiple solutions. Green. Okay. Solving absolute value is similar, and then we're going to add or subtract, multiply or divide to get the bars alone, and then undo the bars. Undo the bars by considering the positive number and the negative number. The positive distance number and the negative distance number are going to be the two numbers that are a given distance away from 0 on the number line. Let's see what that looks like. So if I were to cover up the equation, just like we did with our forward steps, and plug in a variable for a value for k and evaluate like middle school, the first thing I would do is times by 3. So my forward steps would be times by 3. And then I would take the absolute value. So how do I undo? How do I reverse undo to get my solving steps? Well, what undoes absolute value? I'm going to call that break it up. So I'm going to break up the absolute value bars by setting it equal to the positive distance number and the negative distance number. For a step, I'll call that break it up. Break it up. Break it up. Then I'll undo timesing by 3 by dividing by 3. Let's go ahead and see what this looks like. So my first solving step would be break it up. Break it up into two separate equations. One where I take the quantity inside the bars, 3k in this case, instead equal to the positive distance number. And one where I take the quantity inside the bars, 3k, instead equal to the negative distance number. What number is one step away from 0 on the number line? That's the trick. 1. And what other number is one step away from 0 on the number line? Negative 1. So I'll continue on dividing both sides by 3. I'm just going to do it with two different paths. Two different paths. I get k equals positive 1/3. I get k equals negative 1/3. And again, guys, multiple solutions. So instead of solving absolute value bars, when I'm solving squaring equations, we have to be on the lookout for more than one solution. You guys are doing great. We have one more topic. That's the rewriting formulas part. And we'll just have enough time for our closing today. So it's going to work out perfectly. Everybody, let's continue sometimes we're not solving for a variable, right, in terms of just values like 7/3 or 116/8. Instead, we're going to be solving a formula, right, for a variable in terms of other variables. So let's go ahead and rewrite this formula by solving for h in terms of b and r. So on your sheet, you've got b equals pi r squared h. Let's go ahead and list our forward steps. Let's go ahead and list our forward steps. If I wanted to evaluate this expression by plugging in something for h, the first thing I would do is times by pi r squared. So I can simply evaluate by multiplying my value of h times pi times r squared. So my forward step is but one thing, which means the solving step is but one thing. I can do it all in one fell swoop. I undo multiplication of pi r squared by dividing by pi r squared. I just need to do it by the whole shebang. So when I solve this, I can do it in one step. I just have to divide both sides by pi r squared all of the time. In this way, I get rid of the pi, I get rid of the r squared, and I have h, the variable that I wanted alone by itself. H would be in terms of b and r. What does that mean? It means that it's set equal to an expression that has b's and r's in it. What would h equal? That equals b over pi r squared. It sounds like alphabet soup, but we have successfully solved for h in terms of b and r. So that's a good way to do one step. We just have to undo that multiplication, which we all want. Alternatively, we could do it one at a time, but that would have taken forever. We divide by pi, then we divide by r squared separate times, then we have a compound fraction, that's a mess. Then we have to multiply by the reciprocal and flip the fraction, and then, right? So it takes forever. We can do it in one step, and that's the end of it all. Alright, let's solve for h again. Where's my h? H is right here. This is a good example of how we can do more than one step. I'm going to do my forward steps. The first thing I would do is times by 1/2, and then I would times by b1 plus b2. Alright, let's reverse and undo those. So, to reverse and undo those, I would divide by quantity b1 plus b2. And then divide by 1/2. So over here, I'm going to go ahead and take my solving steps. I'm going to divide both sides. Divide both sides by b sub 1 plus b sub 2. That gives us a over b sub 1 plus b sub 2. Equals, what do I still have? Still have the 1/2, still have the h. Now I need to divide by 1/2. But keep in mind, dividing by a fraction is the same as r reciprocal, multiplying by higher tier letter, multiplying by the reciprocal. So I'm now going to divide by 1/2. Dividing by 1/2 is the same as timesing by 2. Okay, timesing by 2 over 1. So my final answer would be 2 times a, 2a over 1 times b plus b. So 2 b sub 1 plus b sub 2 equals h. And I can certainly rewrite that with the variable first. But in the interest of time, today I'm going to box it. We're one to go with our pendulum. And then we'll be got just enough time for closing. So let's go ahead and take a look at our pendulum. The period t of a pendulum is the time in seconds it takes the pendulum to make one complete swing back and forth. It's calculated by the formula p equals 2 pi times the square root of L over G, where L is the length of the pendulum in meters, and G is that acceleration due to gravity, 9.8 meters per second squared for near the surface of the Earth. It's kind of like that Mars acceleration gravity problem in your assignment last night. So let's go ahead and rearrange this formula for L. I'll learn to solve for L. I can list my forward steps. My forward steps would be covering up the equal sign. Plug in something for L. The first thing I would do would be what? I divide by G as my first forward step. So, dividing by G. Then I would take the square root. Then I would times by 2 pi. Everybody see that? So first would be divide by G, then take the square root. Notice I don't have to do plus or minus here. This is the forward step. I'm not undoing the squaring. I don't need a plus or minus here. It's just right there. It's only the positive squaring. Then times by 2 pi to finish it out. So how do I reverse it to get my solving steps? Easy cheese. The last forward step was times by 2 pi. The first solving step is divide by 2 pi. You guys are rocking it. Then I undo square rooting by squaring. I raise the second. I undo division by g by timesing by g. This is going to be great. Let's try it. So solving steps. Multiply both sides by g is my first. I'm sorry. Divide both sides by 2 pi is my first step. So p over 2 pi equals dividing both sides by 2 pi gets rid of the 2 pi, and I get root L over G. Next step, square both sides. Square. Square. So my middle solving step was square both sides. What does that do? Well, I get P over 2 pi quantity squared equals, and I get the square root squared gets L over G alone. Gosh, we're close. So close I can almost taste it. It looks like I'm going to finish it out by timesing both sides by G. So multiplication by G will finish it out. And finally I'll get L alone. I get L equals G times quantity P over 2 pi close quantity squared. The G's not squared, just the parentheses are squared. We can simplify that more when we get to our exponents chapter in Unit 3, but now we'll leave it like this in the interest of time. And now we can use that formula to do something. Use that formula to do something. We can determine the approximate length of the pendulum, whose period is 5 seconds. We do that by plugging in my period P is 5 seconds. Plug that in right there for P and work it out. But we're not going to do that. Instead, we're going to go ahead and write down a written response for our closure and fill in the blank for our hangman game. Here's a blank. So let's see if we can write down what does the order of operations have to do with solving equations and rewrite formulas, and what does that expression mean? So what does order of operations have to do with solving equations and rewriting formulas? Taylor? Absolutely. We can get our solving steps. Give us our recipe for solving steps. It gives us our solving steps. Thank you, Taylor. You can simply do number 2's answer. Who's got the blanks? You can kind of see it if you swing your eyes. Who's got the blanks? Mark? Reverse and undo. So if we reverse and undo our forward steps, we get our solving steps that Taylor was talking about. You guys are awesome, and thanks for making this work out. I'm going to decimal approximation here. Don't forget assignment number 2. Watch that to the top and have a great weekend. It's nice to meet you. I look forward to with your class. Don't forget your binders with labels and extra points on Tuesday. You guys are great. All your stuff for assignment number 2 is on your assignment sheet.
Students have items each up in the bank office. Lauren Lisa Stevens, Aaron Schreiber, Brandon Wagner, Emily Perez, Devin